So today we're going to start a new topic, which is statistics. Statistics is defined as the collection, analysis, organizing, and interpretation of data. So this is the collection, analyzing, organizing, and interpretation of data. And the data can be collected through surveying, doing an experiment, measurement, or recording. Then we're going to look at some of the measurement of central tendency. So we're going to look at mean, median, and mode. So the mean, we'll start with the mean. So the mean is found by saying the sum of numbers divided by the number of those numbers. So this is found by the sum of numbers or scores divided by number of scores. Number of scores that you are given. So for example, if you have been given 2, 4, 5, 5, 5, 1, 0, 2, 1, 5, and you have been told to calculate the mean. So we're going to say mean is equal to sum of the numbers or scores divided by number of scores. So our sum, we're going to say 2 plus 4 plus 5 plus 5 plus 5 plus 1 plus 0 plus 2 plus 1 plus 5 divided by the number of the scores that have been given. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. And if you add all those numbers, the answer is 30. So I have 30 divided by 10. So I'm going to have mean is equal to 30 divided by 10, and my answer will be 3. So that's my mean. Then let us look at the mode. So the mode is the number that has the highest frequency from the dataset. So this is the number that has the highest frequency from the data set. So if, for example, you have been given these numbers, you have 0, 1, 9, 5, 12, 0, 1, 0, 1, 0, and you have been told to find the mode from this data set. So the mode is the number that has the highest frequency, and as you can see here, the zeros they are appearing 4 times. So here the mode will be 0. Then now let us look at the median. Now let us look at the median. So the median is the value that is on the middle in a data set. So this is the value that is just on the middle in the data set. So if you have these numbers, if you have 6, 5, 1, 2, 9, and you have been told to find the median. So before you find the median, first of all, you need to place the numbers in ascending order. So you need to place them in an increasing order. So let us do that. So we have 1, 2, 5, 6, 9. So I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And the other thing that you're supposed to know is that when you count those numbers that have been given in the data set and the number that is and they are being given an odd number, for example 1, 2, 3, 4, 5, that's an odd number. So if you count your numbers and the total numbers of the data set is giving you an odd number, you can just use this formula which says n plus 1 divided by 2. And since here our total number of scores is 5, so we're going to say 5 plus 1 divided by 2, which will be 6 divided by 2 and a half, 3. So here the median is found on the third position in the data set. So here to find the median, we're going to say 1, 2, 3, and my 5 here will be our median. So median will be 5. But if you don't want to use this simple formula, you can just count. You can just count 1, 2, 3, 4, 5, and you can just look at the number that is on the middle, and the number that is on the middle there, it's 5. Let us look at another instance. So let us look at when the total numbers is giving you an even number. So for example, if you have 1, 10, 1, 10, 8, 6, 6, 4, 2, then you have 11. So I have 1, 2, 3, 4, 5, 6, 7. Then I also have 12. So as I count the total numbers, it will give me an even number. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is an even number. So here the first thing, I need to place them in an ascending order. So I have 1, 2, 4, 6, 8, 8, 11, 10, sorry, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, this is not an odd number, so we cannot use that formula. So here we just need to count. So we need to start counting from here. 1, 2, 3, 4, and here 1, 2, 3, 4. So as you can see here, the numbers that are on the middle, I have 6 and 8. So I'm going to add 6 plus 8, then I'll divide by 2. So 6 plus 8, that's 14. 6 plus 8, that's 14. So that is going to give me 14 divided by 2, which is 7. So my median there will be 7. So that's how you find the median, the mode, and the mean for ungrouped data. So that's for ungrouped data. Let us look at another situation. So if you have been given data in this form, So if you have been given data in that form, you have been given 1, 2, 3, 4, 5, 6, 7, 8 with their frequencies, and you have been told to calculate the mean, the median, and the mode. So we're going to write this in this form. So we're going to write this in this form. So the first number they have 1 and the frequency is 10. So 1 multiplied by 10, and the reason why I'm trying to calculate the mean. So 1 multiplied by 10, that's 10. Then the second one I have 2, so 2 and the frequency that's 6. 2 multiplied by 6, that's 12. Then I have 3, the frequency of 3 is 9. 3 multiplied by 9, that's 27. Then I have 4. So 4, the frequency there, it's 11. 4 multiplied by 11, that's 44. Then I also have 5. 5, the frequency there is 7. 5 multiplied by 7, that's 35. Then I also have 7. I also have 7. So I don't have space that side, so I'll continue here. So I'll say my x, my f, and my f of x. So I also have 6. So 6, the frequency there, it's 4. 6 multiplied by 4, that's 24. I also have 7. The frequency there, it's 2. 7 multiplied by 2, that's 14. Then I also have 8. The frequency of 8, it's 1. 8 multiplied by 1, that's 8. So here I'm supposed to add all the frequency. So 10 plus 6 plus 9 plus 11 plus 7 plus 4 here plus 2 plus 1. My answer is 50. And I'm also supposed to add f of x. So 10 plus 12 plus 27 plus 44 plus 35 plus 24 plus 14 plus 8. The answer is 174. And for me to calculate my mean, and sorry, I'm going to write the mean here because I don't have enough space. So I'll say mean is equal to f of x divided by f. So we know that f of x, that's 174 divided by f, which is 50. So when you punch that in the calculator, when you say 174 divided by 50, the answer is 3.48. So the mean is 3.48. The mean there is 3 point. So I'll just write it here so that I have the space of the median and the mode. 3.48. Then let us calculate the mode. So the mode is the number that has the highest frequency, and the number that has the highest frequency there, it's 4, because the frequency of 4, it's 11, and there's no number that has that has the highest frequency of that has the highest frequency than that of 4. So there, the frequency here, as you can see, our 11 is the highest frequency. So the mode there, it's 4. So I'll just put it here. We have some space. Our mode is equal to 4. Then now let us find our median. So median is found by using this formula. MD is equal to the summation of the frequency divided by 2. So the summation there, it's 50 divided by 2, and the answer is 25. So let us find our median. So let us try to add the frequency. So we are going to start with this frequency, which is 10. We're going to say 10 plus 6. So 10 plus 6, and the answer is 16. Then 16 plus 9, and the answer is 25. So if I add 10 plus 6 plus 9, my answer is 25. So this means that the median is 3. So our median there is 3. So I'll just put it here on top. Our MD is equal to 3. Let us now look at on how you can find the median mode and the mean of group data. So if you have the data that you have been given in this form, so D stands for diameter and N just stands for the frequency. So you have been given this data in this form. You have 65 to 67. You also have 68 to 70. Then you have 71 to 73. 71, 73. Then you also have 74 to 76. You also have 77 to 79. Then you have 80 to 82. And the frequency they have been given, that's 2, that's 5, that's 3, that's 4, that's 4, that's 2. So as you can see, that information that have been given is group data because it is in intervals. And if you have been told to calculate the mean, median, and mode, you calculate it in this way. So first of all, you need to make a table. So the first table here, we're going to have our intervals, which is the diameter. Then the next column, we're going to have the midpoint. So you can say the midpoint. Then the third column, we're going to have the frequency. Then the fourth column, we're going to have f of x. So here our first diameter, we have 65 to 67, and the first thing here, you're supposed to find the midpoint, and we find the midpoint by adding these two numbers, then you divide by 2. So 65 divided by 67, the midpoint will be 66, and the frequency of 65 to 67, we know that that's 2. And to find our f of x, we're going to multiply 66 multiplied by 2, and the answer there is 132. So we're going to go to the second one, and we're going to do the same. So 65 to 70, there the midpoint is 69, then the frequency there, we know that that's 5. 69 multiplied by 5, that's 345. Then we're going to do the same with 71 to 73. So when we add 71 plus 73 divided by 2, that's 72, and we know that the frequency of that diameter, that's 3. So 3 multiplied by 72, that's 216. Then we also have 74 to 76, 74 to 76, so that's 75, the midpoint, and we know the frequency of that, that's 4. 75 multiplied by 4, that's 300. Then we also have 77 to 79, the midpoint there, that's 78, the frequency of that, that's 4. 7 multiplied by 78, that's 312. Then we also have 80 to 82, the midpoint there, it's 81, the frequency of that, that's 2. 81 multiplied by 2, that's 162. So there we're going to find the total of the frequency and the total of f of x. So the total of the frequency, so we need to add 2 plus 5 plus 3 plus 4 plus 4 plus 2, and the answer there, it's 20. Then we are also supposed to find the sum of f of x. So 132 plus 134 plus 216 plus 300 plus 312 plus 162, the answer there is 1467. So the first thing that we're going to do is to find the mean. So we find the mean by saying the summation of f of x divided by the summation of f. So the summation of f of x, that's 1467. So 1467 divided by the summation of f, that's 20. So 1467 divided by 20, that's 73.65. So that's the mean. Then let us calculate the model class. So the model class, so the model, the mode we said this is the number that has the highest frequency, and to calculate the model class, we're going to find the class that has the highest frequency. So the model class is 68 to 70, because the highest frequency is 5. So there the model class is 68 to 70. Then let us find the median. So the median, we say the summation of f divided by 2, and we know that our summation there, it's 20. So say 20 divided by 2, that's 10. And find the median class there. We're going to add the frequency, and the one that is going to give us 20, that will be our answer. So if we say 2 plus 5, that's 7, plus 3, that's 10. So that means that our median class will be 71 to 73. So we're going to continue looking at statistics, and today we're going to look at range and other things. So range, this is the difference between the highest and the lowest number of the dataset that you have been given. So this is the difference between the highest and the lowest number of the dataset that you have been given. And the formula that we can use for finding range, we can say range is equal to highest minus the lowest measurement that you have been given. So taking for instance, if you have been given class A, the scores for class A were 90, 90, 90, then we have 70, we have 60, we also have 30. So to find the range of this class A, we're going to say range is equal to highest minus the lowest measure. So the highest measure here, as you can see, is 90. So 90 minus, then the lowest is 30. Then if we say 90 minus 30, that's 60. So that means the range there is 60. Let us look at another example. So for class B, so if class B, you have these scores, you have 70, we have 70, we have 65, we have 55, we have 55, then we also have 35, and you have been told to calculate the range. So we're going to say range is equal to the highest measure minus the lowest measure of the dataset that have been given. So the highest measure there is 70 minus the lowest measure, that's 35. So 70 minus 35, the answer is 35. So that's the range. Where you have questions, you can ask in the group. Let us look at the second thing. Let us look at quartiles. So the quartiles divide the measures into 4 equal parts, and we have different kinds of quartiles. We have the lower quartile, which is represented by Q1. We have the middle quartile, which is represented by Q2, and sometimes the middle quartile, it is referred to as the median quartile. Then we also have the upper quartile, which is represented by Q3. So these are the types of quartiles. So let us look at them. We have said we have the lower quartile, which is represented by Q1. Then we have the middle quartile, which is represented by Q2. We also have the upper quartile. Which is represented by Q3. Let us look at some of the examples. So for the first example, if you have this information, you have 11, you have 11, you have 11, you have 6, you have 6, you have 7, you have 10, you have 9, you have 9, you have 9, and you have 8, and you have been told to calculate you have been told to find the lower quartile, middle quartile, and the upper quartile. So the first thing that we're going to do is to arrange these numbers in ascending order. So the lowest number there is 6. So we have 6, 6. Then we have 7. Then from 7 we have 8. 8 there, we have 9. We have another 9. We also have another 9. Then from 9 we have 10. Then 10 there, we have 11. We have 11 and another 11. So we have arranged these numbers in ascending order, and let us count these numbers. These numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these numbers are 11, and the first thing that you're supposed to find is the middle quartile. And for the middle quartile, we can just use the same as that of the median. So as you can see here, the numbers is giving us an odd number. So to find Q2, we can say n plus 1 divided by 2, and we know that the total number there is 11 plus 1 divided by 2, so that's going to be 12 divided by 2, which is 6. So to count here, 1, 2, 3, 4, 5, 6 there. That means there our Q2, it's our Q2 there, it's 6. And since we have identified our Q2 there, it's very simple to find Q1 and Q3. So here we can say our Q2, that's 9. So to find our Q1 here, we are going to consider this arrangement, which is this side. So before we reach the median, so these numbers, so we are going to exclude our median, and we are going to count these numbers 1, 2, 3, 4, 5. And since these they are 5, we know that here the number which is on the middle is 7. So here our Q1 is 7. Then let us look at our Q3. For the Q3, we are going to do the same. We are going to consider the numbers after our median. So after our median here, we are going to exclude our median, our Q2. So here we're going to consider 1, 2, 3, 4, 5. And since the number there is 5, we can count here 1, 2, 1, 2, and the number which is on the middle is 11. So there our Q3 is 11. So that's how you can find the lower quartile, the upper quartile, and the middle quartile if the total numbers of the data set is giving you the odd number. Let us look at another instance if the total number is giving you an even number. So for this another example, I have information which is 13, 12, 12. Then I have 4. I have 14. Sorry, this is 14. I have another 14. I have 15. I have 10. I have 11, I also have 11. So the first thing is to arrange these numbers in ascending order. So the lowest number there is 10. So from 10, I have 11, I have 11, I have 12, I have 12, I have 13, I also have another 13, I have 14, I also have another 14, then I have 15. And let's count the total number of these data that have been given. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as you can see, the total number is giving us an even number. So the first thing that we're supposed to do is to calculate our middle quartile. So let us calculate here. Let us start counting 1, 2, 3, 4, 5. And from this side, if we count 1, 2, 3, 4, 5. So as you can see, these two numbers here, they are forming the middle quartile. We have 12 and 3. And to calculate our middle quartile, we're going to say 12 plus 13, sorry, not plus 3, but 12 plus 13. So 12 plus 13 divided by 2 there. And if you do the calculations, 12 plus 13, that's 25, divided by 2, the answer will be 12.5. Then since we have known our Q2, it will be very easy for us to calculate Q1 and Q3. So to calculate Q1, we are going to consider these numbers. So we're going to consider 10, 11, 11, and 12. So if you start counting there, it's 1, 2, 3, 4. And as you can see, the two numbers that are on the middle there is 11 and 11. So to calculate Q1, I will say 11 plus 11 divided by 2. And 11 plus 11, that's 22, divided by 2. My answer will be 11. Let us calculate Q3. To calculate Q3 there, we're going to consider the numbers after our Q2 there. So we're going to consider 13, 14, 14, 15. And as you can see, the two numbers that are in the middle, we have 14 and 14. So we're going to say 14 plus 14 divided by 2. So our Q3 will be 14 plus 14, that's 28, divided by 2, that's 14. So that's how you can calculate Q1, Q2, and Q3. Let us look at the interquartile range and the semi-interquartile range. So the interquartile range, which is represented by IQR, is found by saying IQR is equal to our Q3, which is our upper quartile, minus our lower quartile, which is Q1. So that's the formula that you use in the formula for finding the semi-interquartile range. So the semi-interquartile range, we say our Q3 minus Q1 divided by 2. So if you want, you can just say the interquartile range divided by 2. That's the formula of finding the semi-interquartile range. Let us look at the cumulative frequency table. So the cumulative frequency table usually has columns which consist of the data values, the frequencies, and the cumulative frequencies. And for this example, we're going to use this information. So if we have that information, so from that information we have day absent 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we also have the frequency. So the frequency of 0 is 2, the frequency of 1 is 3, the frequency of 2 is 6, the frequency of 3 is 7, the frequency of 4 is 6, the frequency of 5 is 9, the frequency of 6 is 11, the frequency of 7 is 6, the frequency of 8 is 0, and the frequency of 9 is 2. And you have been told to construct a cumulative frequency table. So you need to include the data values, the frequencies, and the cumulative frequencies. So we know days of absent, that's 0, and the frequency there it's 2. Then our cumulative frequency of that is going to be 2. Then for 1, the frequency there is 3, and to find the cumulative frequency we're going to add 2 plus 3, and the answer will be 5. Then we also have 2 there. Then the frequency of 2, that's 6. Then we're going to say 6 plus 5, that's 11. Then we have 3. The frequency of 3, that's 7. 7 plus 11, that's 18. Then we also have 4. The frequency of 4, there, that's 6. 6 plus 18, that's 24. Then we also have 5. The frequency of 5, that's 9. 9 plus 24, that's 33. Then we also have 6. The frequency of 6, that's 11. 11 plus 33, that's 44. So as you can see, there's no enough space, but you can complete that cumulative frequency table. So that's how you find the cumulative frequency table. Where you have questions, you can ask in the group. So today under statistics, we're going to proceed. We're going to look at the cumulative frequency table and the cumulative frequency curve. And we're going to use question 9. And this question, I've just gotten it from the past paper of 2015. So question 9 reads, on a particular day, a tuck shop owner recorded the expenditure of 350 boys, and the results were as shown in the table below. So as you can see, that's the table. Question A reads, calculate the mean amount of the money spent. So we know that the formula of calculating mean is written in this form. So the first question, we are supposed to calculate mean, and we know we find mean by saying the summation of f of x divided by the summation of f. But it is first important to identify if this information that we have been given is group data or ungrouped data. So this data is group data. So for us to calculate x, which is the midpoint, we're going to add the two numbers, then we divide by 2. So for the first one, 10 to 20 divided by 2, that's 15. Second one, 20 to 30 divided by 2, that's 25. So we are going to do the same. So we'll be multiplying the midpoint multiplied by the frequency. So that's going to be the summation of f of x. And to write this down, we are going to say, so summation of f of x, So the midpoint for the first one, which is 10 to 20, is 15. So we're going to say 15 multiplied by the frequency, that's 20. So we're just going to do the same. For the second one, we have the midpoint, that's 25, multiplied by its frequency, that's 50, plus we also have 35 multiplied by 55, plus then we have 45 multiplied by, then the frequency there, it's 70. So multiplied by 70, then plus we also have 55 multiplied by 60, plus 65 multiplied by 45, plus you have 75 multiplied by 35, plus we have 85 multiplied by 10, plus we have 95 multiplied by 5. So divide by the summation of f. So the summation of f, we're going to add all the frequency. And the frequency, we have 20 plus 50 plus 55 plus 70 plus 60 plus 45 plus 35 plus 10 plus 5. So if we multiply the numbers on the top and we add them, the final answer will be 16,800 divided by, if we add all the numbers on the bottom there, we're going to have 350. And if we divide there, our mean is going to be 48. So that's our mean. Our mean is 48. Then question B reads, copy and complete the cumulative frequency distribution. So we have been given the table there, so we are supposed to fill in here and here. Supposed to fill in there and there. And for us to fill in there, what we're going to say, we're going to go where there is 80. And where there is 80, it's here, as you can see. This is where our 80 is. So for us to find the number here, we're going to say 300 plus 35, and that's 335. Then to find the number here, 335 plus 10 is 345. Then 345 plus 5, that's 350. Then question C reads, using a horizontal scale of 2 cm to represent 10 kwacha and a vertical scale of 2 cm to represent 50 boys, draw a smooth cumulative frequency curve. That's 3 marks. So the horizontal scale must be 2 cm to represent 10, and from these numbers on the top, as you can see, the numbers are ending on 100, so our divisions must be up to 10. Then here the numbers are ending up to 350, and our divisions must be 7. So let's just draw that. And to draw that, I'm just going to draw not an accurate diagram, but just an estimation. I'm not going to use a graph. This will just be an estimation. So the horizontal scale, we have been told it must be 2 units must represent 10. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, then I have 100, and this is my x-axis. So I know that my my x-axis there represents amount, so I'm going to indicate my amount there. I'll indicate amount. Then on the vertical scale, it says 2 centimeters must represent 5. It must represent 50, sorry. It must represent 50. Let me just say that. It's 50 boys. So I have 50, 100. I have 150. I have 200. I have 250. I have 300. And I'll also have 350 here. And this represents the number of boys, and that's the y-axis. So let us plot our graph. So the first coordinate is 10, 0. So 10, 0, it's here. That's our first point. Then the second one, it's 20, 20. So 20, 20, since this is an approximation, I'll just put it here. This is just an approximation, it's not drawn to scale. So the next one, I have 40, the third one, sorry, I have 30, 70. So 30, 70. If this is 50, we're going to say 70, it's here. Then the other one, I have 40, 125. So 40, 125. So 125 is going to be on the middle there. Then I also have 50, 195. So 50, 195 to be somewhere here. I also have 60, 255. 60, 255. So it will be somewhere here. I also have 70, 300. So 70, 300. Somewhere here. Then I have 80, 335. 80, 335. Then I also have 90, 345. So 90, 345. Then the last one, I have 100, 350. So 100, 350. And to draw my curve, I'll just connect the points. So that means I've drawn my cumulative frequency curve. Let's continue looking at the other questions. Question D reads, showing your method clearly, use your graph to estimate Roman numeral 1, the median, Roman numeral 2, the interquartile range. So Roman numeral 1 says we're supposed to calculate the median. So for the median, so this is question what? This is question D, Roman numeral 1, the median. So the median is the same as the middle quartile. So middle quartile is Q2, and we're going to say Q2 half there multiplied by 350, which are the number of boys, and 350 divided by 2, that's 175. So that's 175, and let us plot 175 on that graph. So here we know that 200, 150, so 175 to be somewhere here. And we're also going to estimate that this, if this is 40, this is 50, this one can say this can be 48. So that means there our median is 48. So the median there is 48. Then let us look at Roman numeral 2, which says the semi-interquartile range. So for the semi-interquartile range, which is Roman numeral 2, so semi-interquartile range, we know this is given by interquartile range divided by 2, or we can say Q3 minus Q1 divided by 2. So we're supposed to calculate Q3 and Q2. So our Q3 is equal to 3 divided by 4 multiplied by the number of boys there, which is 350, and this is going to give us 262.5. Then if we say Q1 is equal to Q1, we find it by saying 1 over 4 multiplied by 350, and this is going to give us 62. That's not going to give us 62, it's going to give us 87 point. So this is 87.2. So that's going to give us 87.2. So we need to get our third quartile and our first quartile. So we're going to start with 87 point. Let me just do that again. 87.5. So this is 87.5, sorry. 7.5. So let us plot 87.5 there. So we know that this is 100, this is 50. So our 87.5, we're going to say, okay, it's here. And if we come down, we see that's 30. So we know that Q1, that's 30. What about Q3? So Q3, we are going to plot 262.5. So 262.5. So we know that's 200, that's 250. So 262, we are going to say it's somewhere here. 0.5. And as you can see, that coordinate was in line with 60. So I have 60 there. So I know that my Q3, that's 60. So we have done our calculations there. So let us now find our semi-interquartile range. So we already know the formula there. It's Q3 minus Q1 divided by 2. So our Q3, so we're going to say semi-interquartile range is equal to our Q3, that's 60 minus 30 divided by 2 there. So our answer there is going to be 30. 60 minus 30, that's 30. Then divide by 2. 30 divided by 2, that's 15. So that means our semi-interquartile range is 15. Let us look at the other question. The other question reads, given that those who spent 75 kwacha or more qualified for a draw in a competition to win a prize, find the number of boys who qualified for the draw. So given that those who spent 75 kwacha or more qualified for a draw in a competition to win a prize, find the number of boys who qualified for the draw. So we're going to get the number of boys that qualified, and for us to do that, first of all we need to go to our x-axis. Since our x-axis represents the amount and we have been told 75, and 75 we know it's in between 70 and 80 there. So it's in between 70 and 80, 75. So let us plot that to the curve. Then from there come this side. Then as you can see, it's giving me that coordinate. Then that coordinate, you said it was what? It's giving me, okay, we're going to just estimate that. We say if we have 250 there, then we have 300. Okay, we can just say, 250, this is 300. You can say this is or 290. So if we say that's 290, to find the number of boys there, so number of boys, that's question what? Let me see question E. So number of boys is going to be equal to the total number of boys, that's 350 minus, we have calculated that 290. So let us do our calculations there. So 350 minus 290, that's 60. So that's 60 there. So that's the number of boys. So that's how you can complete your cumulative frequency table and how you can draw a cumulative frequency curve. Where you have questions, you can ask in the group. So we are going to continue with statistics, and today we're going to look at relative cumulative frequency. So for you to find the relative cumulative frequency, first of all you need to find the cumulative frequency. So that's the first important point that you need to take note. For you to find the relative frequency, first of all you need to find your cumulative frequency. So that's the first point that you need to take note. You need to find your cumulative frequency. And for example, if you have data in this form, so if this is the scores, then you have the frequency here. And if we only have two types of scores, I have 2, I also have 3, then I have 1 and 6. And from this I've been told to calculate the cumulative frequency. So first of all I'm going to write this down. I'll copy it. So in the first row I'll put my score. In the second row I'll put my my cumulative frequency there. So I have my cumulative frequency there. So I have 2 there and 3. So in the first if this is 5, so the frequency of 3 is 5. So here we know that the frequency of 2, that's 1. Then to find the cumulative frequency of 3, we're going to say 1 plus 5, which is 6. So for me to find the relative cumulative frequency for 2 there, I'm going to say the cumulative frequency of 2 divided by the total number of cumulative frequencies. So I'll say 1 divided by 6. So that's going to be my answer. And to find the relative cumulative frequency of 3 there, I'm going to say the cumulative frequency of 3 divided by the total cumulative frequency, which will be 6 divided by 6, and the answer is 1. So that's how you find the cumulative frequency. Let us use another example. So from that question, if we have been told to calculate, write down the cumulative frequency table from this information. So we have fruits per tree, I have 2, then I also have frequency. So 2, the frequency of 2 is 1, the frequency of 3 is 5, the frequency of 4 is 4, the frequency of 5 is 6, the frequency of 6 is 10, the frequency of 7 is 16, and the frequency of 8 is 18. And if I've been taught to write down the cumulative frequency table, I'll write it in this form. So I'm going to write 3 columns, as you can see. Then I have fruits per tree in the first column. I have cumulative, frequency in the second column, and in the third column I have relative, cumulative, frequency. So from the information that we've been given from the fruits per tree, we know that the numbers, they go from 2 to 8. So we have 2 up to 8. So we can say 2 there. Then the frequency of 2, let's check the frequency of 2. It's 1. The frequency of 2, that's 1. Then we also have 3. The frequency of 3 is 5. So the frequency of 3, that's 5. So we know to find the cumulative frequency, we're going to say 1 plus 5, and that's 6. Then I have 4 here. Then the frequency of 4, that's 4. So 4 plus 6, that's going to be 16. So let us complete this table. I also have 5. The frequency of 5, that's 6. So 16, that's 6. So 16 plus, what's this? Let me just try to check. We said that the frequency of 4, it was 4. So 6 plus 4, that's 10. Then I know that the frequency of 5, that's 6. 10 plus 6, that's 16. Then I also have 6. Then the frequency of 6, that's 10. So 10 plus 16, that's 26. Then I also have 7. So I also have 7. Then the frequency of 7, that's 16. So here I'm going to say 26 plus 16, that's 42. Then I also have 8. The frequency of 8 is 18. So I'm going to say 18 plus 16, 18. I'm going to say 18 plus 42, and that's 60. So that's how you find the cumulative frequency. And from this information, we can find our relative cumulative frequency. So for the first number, which is 2, to find our relative cumulative frequency, we're going to say the cumulative frequency divided by the total number of cumulative frequency. So there I'm going to have 1 divided by 60, and 1 divided by 60, that's 0.02. Second one, there I'm going to have 6 divided by 60, and 6 divided by 60, it's 0.1. Then for 4 there, I know the cumulative frequency there of 4, it's 10. So 10 divided by 60, the answer there it's 0.17. Then the cumulative frequency of 5, I know that's 16. So I'm going to say 16 divided by 60. 16 divided by 60, the answer is 0.27. Then the cumulative frequency of 6, I know that the cumulative frequency of 6, that's 26. So to find the relative cumulative frequency, I'm going to say 26 divided by the total number of cumulative frequency there, which is 60. So 26 divided by 60, that's 0.43. Then for this one, I know the cumulative frequency is 42 divided by 60. My answer is 0.7. For 8 there, I have 60 divided by 60. My answer there is 1. So that's how you can find the relative cumulative frequency. So it is important first of all to find the cumulative frequency. After you find the cumulative frequency will help you to find the relative cumulative frequency. Where you have questions, you can ask in the group. So we continue. Now we are going to look at the standard deviation for ungrouped data. So for you to find the standard deviation, first of all, you need to know your mean. So the formula for finding mean for ungrouped data, we say mean, which is represented by x and a bar, is equal to the summation of the scores divided by the number of scores. And the formula that we use to find standard deviation, you can use two formulas. So the first formula is the summation of x minus the mean squared divided by the number of scores there. And the other formula that we can use, we can also say standard deviation is equal to the square root. We have the summation of x squared divided by the number of scores minus the square mean squared there. So those are the two formulas that you can use. You can either use this one or this one to calculate the standard deviation. And for this example, we are going to use this information. So if you have been given information in this form, so you have been given 4, 5, 6, 8, and 12, and you have been told to calculate the standard deviation for this ungrouped data. So the first thing that you need to find there is the mean. So the mean for ungrouped data, we know is equal to the summation of x divided by the number of scores. And from this information that we have been given, we are to find the summation of x, we are going to add all the numbers that we have been given. So we are going to say 4 plus 5 plus 6 plus 8 plus 12 divided by the number of these scores. So these, they are how many? We start counting 1, 2, 3, 4, 5. So these are 5. And to calculate the mean there, 4 plus 5 plus 6 plus 8 plus 12, the answer is 35. So 35 divided by the number of scores there, it's 5. So the mean there is equals to 35 divided by 5, it's 7. And since we know the mean there, let us calculate the standard deviation. And for this standard deviation, we are going to use this formula, we use the first formula that we wrote, summation of x minus x, the summation of we have the summation open bracket x minus the mean squared divided by n there. And from this we can just write down a small box. So as you can see, I have written 4 columns. The first column I have x, which represents each score. Then I have x and the bar, which represents the mean. I have x minus the mean. Then I have x minus the mean squared. So the first score, what do we have? The first score we have 4, and we know that there the mean is the same. We calculated the mean as 7, so we're going to say 4 minus 7 there, and our answer is -3. -3 squared, that's 9. Then we're going to come to the second one. We have 5, then our mean there is 7. 5 minus 7, the answer is -2. -2 squared, that's 4. Then we have 6. Our mean is 7. 6 minus 7 there is -1. Then -1 squared, that's 1. Then I also have 8. My mean there is 7. 8 minus 7 is 1. 1 squared, that's 1. I also have 12. My mean there is 7. 12 minus 7 is 5. 5 squared is 25. So there we are going to find the summation of the column of x minus x squared. So we're going to say 9 plus 4 plus 1 plus 1 plus 25, and the answer there is 40. That's our answer. So we are going to use that answer to find the standard deviation. So as we wrote the first formula, we said standard deviation is equal to the summation open bracket x minus the mean squared divided by n. And this we have found, which is on the top, we have found from the table. We have calculated that it's 40. As you can see, that represents this. From the formula, the top part of the formula represents that column. So I have 40 there. So I'm going to say the square root of 40 divided by, this represents the number of scores, and the number of scores that we have, it's 5. So our SD is equal to 40 divided by 5, that's 8. So I have 8 there. Then I'll say SD is equal to, so the square root of 8, going to have 2.82842712. Let me just prove that one. The square root of 8, 125. Then I'm going to round off to 2 decimal places. So I'll cut here 2.83. So that's my standard deviation. So that's how you calculate the standard deviation and the mean for ungrouped data. So for the same data set, let us also try to use this other formula. So the other formula, which is SD, the other formula, which is SD, is equal to the square root of summation of x squared divided by n minus the summation of x squared divided by n minus, then we have mean squared here. Let us also try to use this formula. So for this formula, we're going to draw the table in this form. So I'm just going to have x and x squared. So for the first square, I have 4 squared, that's 16. Then I also have 5 squared, that's 25. Then I also have 6 squared, that's 36. Then I also have 8 squared, that's 30. 8 squared, that's 64. Then I also have 12 squared, that's 144. So I also have 12 squared, that's 144. And to get the total number of those numbers that I've calculated, I'm going to say 16 plus 25 plus 31 plus 64 plus 144. The answer is 284. I also know it's 285, sorry. Then from the previous formula, we had calculated our mean. Our mean we had calculated to be 7. Then we also know that in the formula we have mean squared. So we're going to say 7 squared there. 7 multiplied by 7, that's 49. So let us replace in the formula. So from the formula, the other formula, we know standard deviation is written in this form. So the summation of x squared we have calculated to be 285. So this column here, this column represents the summation of x squared. So it is 285. So I'm going to say 285 here, divide by the number of scores. I know that's 5 minus mean squared, that's 49. Then from this, I can say my SD is equal to 285 divided by 5. My answer is 57 minus 49. So my standard deviation is equal to 57 minus 49. the answer there it's 8. Then my SD is equal to the square root of 8, that's 2.828427125, and if I round off to 2 decimal places, that's going to be 2.83. So as you can see, this answer and the answer that we had calculated above here and this answer here, these two formulas, they're giving the same answer. So you can either use one of those now. Look at the question that came in 2018 for mathematics past paper 2 for GCE, and this was question 11. So question 11 reads, a farmer planted 60 fruit trees. In a certain month, the number of fruits per tree was recorded, and the results were as shown in the table below. So I have that table. The first question reads, A, calculate the standard deviation. So from the data that we have been given, we know that that's group data. So we need to use the formulas for grouped data. And the formulas that we use are written in this form. So these formulas are given in the question. So that's 11 A. So these formulas are given in the question. So before you calculate the standard deviation, it is important to calculate the mean. So the mean there is summation of f of x divided by summation of f. Then if you look at the formulas in the question paper, we know that standard deviation for group data can be in this form. Then it can also be in this form. So these are the formulas that we use when calculating the standard deviation. And for this question, we are going to use this formula. So let us write up our table. So I'm going to have 5 columns here. So as you can see, I've drawn 5 columns. In the first column I have fruits, which represents x. Then I have frequency, have f of x, which means frequency multiplied by x. Then I have x squared. Then I have x squared multiplied by frequency. And from the information that I've been given, I know that the number of fruits in the first the number of fruits that will be given for the first, it's 2, and the frequency of 2, that's 1. So to calculate f of x, I'll say 2 multiplied by 1, and the answer there, it's 2. Then to find x squared, I'm going to say, to find x squared there, I'm going to say 2 multiplied by 2, and the answer there, it's 4. and find my x squared multiplied by frequency. So I multiply this 4 multiplied by 1, and the answer is 4 here. Then I also have 3. The frequency of 3 there, it's 5. So 3 multiplied by 5, that's 15. Then to find x squared, I'll say 3 multiplied by 3, and the answer is 9. Then I'll say 9 multiplied by 5 there, the answer is 45. Then I also have 4. The frequency of 4 is 4. So 4 multiplied by 4 there, it's 16. To calculate x squared there, I'll say 4 multiplied by 4 is 16. 16 multiplied by 4 there, the answer is 64. Then I also have 5. The frequency of 5, that's 6. Then f of x, I'm going to have 30 there. Then x squared, I'm going to say 5 multiplied by 5, that's 25. Then 25 multiplied by 6 there. 25 multiplied by 6, my answer is 150. Then I'm also having 6. The frequency of 6 there, it's 10. 6 multiplied by 10, that's 60. X squared, I'll say 6 multiplied by 6, that's 36. 36 multiplied by 10, that's 360. Then I also have 7. The frequency of 7, that's 16 there. Then I'll say 7 multiplied by 16, the answer is 112. Then I'll say to calculate x squared, 7 multiplied by 7, the answer is 49. Then 49 multiplied by 16, the answer is 784. 784. Then I also have 8 there. The frequency of 8, I know that's 18. 8 multiplied by 18. 8 multiplied by 18, that's 144. Then to calculate x squared, I'll say 8 multiplied by 8, and the answer is 64. 64 multiplied by 18, the answer is 1152. Then let us calculate the totals there. So the totals there, we'll start adding all these columns for fx, x squared, then x squared f. So for the first, for this column of f, the total is going to be 60. And if you add these numbers up, your answer is going to be 379. And for this column, it's going to be 203, and for this column it's going to be 2559. 9. And if you reach here, that means you're halfway done. The only thing that you need to do is to replace these numbers into your formula. So the first thing that we're going to do, we're going to calculate the mean. So we know that the mean is found by saying the summation of f of x divided by the summation of f, and the summation of f of x there, let us see from the table. So f of x, it's 379, and you can see from our column, our f multiplied by x, our frequency multiplied by x is that column. So to calculate that, we're going to say 379 divided by the summation of f. The summation of f, we know that it's this column here. So we're going to get the number which is on the bottom, which is 60 there. So we know that's 60. And our mean there is going to be 379 divided by 60 is 6.31. Then I have 1, 2, 3, 4, 5, 6. Then I have 7. So the mean there, round off to 2 decimal places, I'm going to have 6.32. So as you can see, that's our mean. And since we have calculated our mean, let us calculate the standard deviation. So standard deviation is equal to, we're going to use this formula, which says the summation of fx squared divided by the summation of f minus x, mean squared there. And from that we can start replacing. We know that the summation of fx squared is this number, which is 2559. So we are going to replace that. So that's 2559 divided by our summation of f. We know that's 60 minus then the mean squared. Our mean, we know that our mean we had calculated is 6.32. So we're going to say 6.32 squared there. So 2559 divided by 60. So I'll say my SD is equal to 2559 divided by 60. The answer there is 42.65 minus 6.32 multiplied by 6.32. The answer there is 39.94. And if you do your subtraction there, the answer is going to be, so the square root of 2.7076. And to find the square root of that, standard deviation is going to be 1.65. So that's how you can calculate that standard deviation. So you can just finish up this question. Yeah, where you have questions, you can ask in the group. So at Just Production, we provide the following services. we sell some past papers with answers. And the past papers that we have 2017, 2018, 2019, and 2020. And these past papers, you can get them at both hard copy and soft copy. For the soft copies, they are only going at 20 kwacha per paper. So that means if you want paper 1 for 2020, you just pay a 20 kwacha. And after you pay 20 kwacha using Airtel or MTN mobile money, we're going to send it on WhatsApp. Then if you want a hard copy, it is free delivery within Mandef constituency, or we can deliver in town, we can meet in town, and I can give you that hard copy. Then the other service that we provide are just productions that we provide online tuitions. And for the online tuitions, we provide subjects like physics, chemistry, math, and biology. And the price is only 100 kwacha per subject. And for instance, if you want to be learning mathematics, you just pay 100 kwacha, and you are going to be added to a WhatsApp group. And in those WhatsApp group, we actually post videos on a particular topic. And where you have questions, you can ask in the group. So that's how the online tuitions work. So it's 100 kwacha per month, and that's per subject. Then we also sell some books. We sell books for all the grades from grade 10 to grade 12. And these books include for physics, chemistry, math, and biology. And the price is only 10 kwacha per subject, and that's soft copy. And for the hard copies, it's only 25 kwacha. So for further information, you can call me or text me on the number that is showing on the screen, which is 0973023620. Peace. God bless you. The full topic of current electricity is available, and it's only going for sale at 10 kwacha. And after you make a payment using Airtel or MTN mobile money, I'm going to send the video on WhatsApp. And this video includes the following: electrical symbols, current, quantity of charge, direction of current, potential difference, electromotive force, electrical energy, power, electrical resistance, the circuit, series connection, parallel connection, cost of electricity, the 3-pin plug, the fuse.